Hello, algebra students. Today we are going to be adding and subtracting polynomials. So on our last day together, we just talked about what is a polynomial, how do we name polynomials, and today we're going to talk about adding and subtracting those polynomials. That is giving us a really weird glare. Hopefully that helps. Okay, so our essential question is simply, can I add and subtract polynomials? A lot of students really like this unit because they've seen something very similar before. In fact, you've heard this term, like terms. You've heard that before, and it's something that tends to be really easy if you have lots of colors ready. So if you need to pause the video and go get some colors, that is my suggestion, is to have those ready. So the best way to do this is to just dive right in with examples. We're going to start a little, probably easiest to hardest. So let's talk about like terms. Like terms are a term, that's a term, right? And another term that have the exact same number of variables, and those variables are to the same power. So if I had something like this, although those have the same variable x, and x, they have a different exponent. And so in this case, there are two like terms. There are two x's and four x's. And so when you combine those terms, you're going to have six x's. In this case, there is only one x squared. So that's going to be all by itself. You can't add it. I was going to say you don't need to, but you can add it to anything else. So it's more mathematically correct to put all of your biggest exponents first. So biggest exponents and then smallest exponents. And what is 2x and 4x? That is 6x. So that is a very simple problem of what you're going to be expected to do today, is adding up all of those like terms. Let's try another example. 2x squared plus 3x plus x squared minus x. Now there's a little bit to unpack today. Some people like to use colors, some people like to use shapes, like they just want to use a pencil and use rectangles and triangles. Some people like to use colored pencils and shade them in. So however you want to do it, I'm going to try and show you a few different ways. But let's look to see if there's any like terms. There are two sets of like terms. So there's two sets with x squareds and there's two sets with x's. Now I'm going to use some different colors. If you want, again, some people like to use like underlining in one color. Some people like to use shapes. In this case, you have to look at the coefficient. What is the coefficient? What's out in front here? That's a 2. And what's out in front here? That is an invisible 1. That's a positive 1. So you're going to add up those coefficients. You have a 2x squared and a 1x squared, which means you have a total of 3x squareds. Now let's look at the other ones. We have some x's here. I have 3x, and make sure to include any sign out in front. So in this case, it's kind of hard to say that those are two different colors. Sorry. They are two different colors, I promise, but I'll just box those. You want to include negatives because there is an invisible 1 there, right? But you want to make sure that you include that minus symbol out in front. We're going to turn it into a negative symbol. Those are used interchangeably. And if I have a 3x minus 1x or 3x plus a negative 1x, no matter which way you do it, you will have two x's. And at that point, you've combined all the like terms that you possibly can. I've also seen teachers teach it like this, where they combine it down below. And I don't hate that. I think that's another good way of doing it. So if you want to combine it down below by using some arrows, you can too. All right, like I said, we're going to start adding more and more. It might be getting more difficult as we move on. We're going to start adding some exponents. This looks intimidating, or it might look intimidating, but it's not anything different than this. If there is nothing out in front to distribute in, you don't need the exponent or the parentheses. Here, what are you distributing in? What's out in front? A 1. Well, I could distribute the 1, but it's not going to change anything. So I'm going to leave it as that. You don't have to put the parentheses there if there's nothing out in front. And in this case, we're going to combine like terms. Like I said, you could use colors. Some people like to just like combine them together like this. I might use, I'm just going to use colors again. I have 3m squared. Is there any other m squareds? Any others? Nope. So that is 3m squared. And you could do it below too, if that helps. There's an m and an m. Well, m and 2m is 3m. And lastly, we have this -6. And that can't be combined. There's no other constants. So I'm done there. So some people like to use shapes, and that's totally fine. If you don't want to get like a new color or you only want to use your pencil, you can do that. All right, we're starting to add more and more things. So this one is where we start getting a little kind of crazy, a little bit. 2x squared plus 3x minus 1. Write that down. Minus 2 in parentheses. I know, it's kind of crazy. We're adding a few more things. 3x squared plus 3. Okay, so just like I always said up there, if there's nothing to distribute, I'll use a pencil here. Like if there's just a 1 to distribute and you're not changing anything, so when there's a 1, when there's nothing out in front, there's like an invisible 1 out in front, and if you distribute that to everything, then you've got nothing. Then you can't, there's nothing else you change. So it's 2x squared plus 3x minus 1. And over here, is there something to distribute? Yes, we finally have something to distribute. Look very closely. I'm intentionally writing this in yellow because you can barely see it. But you want to include the whole -2. And you're going to distribute that twice. So you want to include all that negative out in front. Even though it's a minus 2 times all of this, we stick that minus and turn it into a -2. So -2 times 3x squared is -6x squared. -2 times a 3 is a -6. And you can write it like that, or you can write plus a negative. Both of those are fine. And then, hey, we're going to combine like terms. I think I'm going to use colors this time. So I have 2x squareds and -6x squareds. Okay, so I could think of it as 2 minus 6, or I could think of it as 2 and a -6, and either way, I'll get a -4x squared. Or I could also write it over here. I'll write it in both places. Okay, are there any x's? Yes, there are. I have, oh, you know what? I just have a 3x. So that's it. And then what else do I have? Oh, look at that. I have a -1 or a -1 and a -6 or a -6. So if I have a -1 and a -6 or a -1 minus 6, I have a -7. And you can use your calculator for that too. I did not circle my answers, but I probably should have, so I'm going to go back and do that once I'm done. But those are the same thing. You wouldn't have to write it 2 times. I was just showing you how different people might write them. So let's add one more example that looks like that. Okay, we're adding a little bit more. 2x squared plus 4x minus 3. If you need to take a pause and write this down or finish up the last problem, please do that. Minus 3 parentheses x squared plus 8. Okay, so we have parentheses, which first thing you need to do is look in front of it. Is there something to distribute? Yes, and for both of them actually. So let's distribute the 2. I'm gonna write this down a little bit farther so that we have more room. That's 2 times 2, 2 times 2, which is 4x squared, 2 times 4, which is 8x, 2 times -3, which is -6. And then we're going to distribute that -3. Distribute the whole thing, please. Just like how we wanted to do up here, make sure to distribute the whole -2. So we're going to distribute the whole -3. -3 times x squared is -3x squared. -3 times 8 is -24. And at this point, we're just finding some like terms. Let me I'll use underlining and some colors. 4x squared, negative 3x squared. So how many x squareds do I have? A 4 and a negative 3, or 4 minus 3 is just 1. What else? You know what? There's only one x. There's just an 8x. So he's all by him lonesome. All by his lonesome. And then I have a negative 6 and a negative 24, or minus 6 and a minus 24. Either way, you'll have those negatives together, and I add those up, and you have a negative 30, or minus 30.